In this video, we're going to talk about how to evaluate this integral using 8 different methods. Normally, if you get an integral like that, these are integrals of secant and tan. We have special substitutions that we normally use. For example, sometimes we use u equal tan theta, other times we u equal secant theta. So that depend on the power of the integral. For example, if you can factor out secant squared term and you can write the rest of the integral using tan, we can use u equal tan theta. And if you can factor out a secant tan theta and you can write the rest of the integral using secant, we can use u equal secant theta. But you can see that there are 6 other methods that you can use for a problem like this. So let's start one by one. So the first method is the most common method for a problem like that. So that is the u equal tan theta. So we can use the u equal tan theta method because that's a straightforward method. So we can start with u equal tan theta, and then what we're gonna do is we can take the derivative of both sides. So if you take the derivative and then multiply by d theta, so you can see that you can write this one as du equal secant squared theta d theta. That's what happens when you take the derivative. So what we're gonna do now is we're gonna factor out a secant square theta for the derivative part, and then also we can use some other identities. For example, we can use identities for this problem secant square theta, which is equals to 1 plus tan square theta. So that means wherever you see secant square theta, you can plug in 1 plus tan square theta, and you can plug in for tan. So let's see how the rest of the calculation works. So we can start with the integral, so which is secant 4 theta tan 3 theta, so cube theta. So and then what we're gonna do is we know that we need the secant square theta for the derivative, so we're gonna take one term out for the derivative. So what we're gonna do, we're gonna take one secant square theta term out. That means we can have secant square theta left here, and then we also have tan square theta, tan cube theta, and then we have that secant square theta d theta for the derivative part, and we are not going to touch that part. So we're going to leave this part for the derivative, because this is the derivative, it's a du. So and then what we can do, we can write the rest of the integral in terms of tan, because that's substitution we can use. So that means we have to use some other substitution here. For example, we can replace secant by 1 plus tan square theta. That's a trigonometric identity. Tan cube theta we can leave because we can substitute for u for that. And then we also gonna leave secant square theta d theta. We are not gonna transform that back because that's a derivative part. Now what we can do, we can substitute. So when you substitute, this can be 1 plus, since tan equal u, so it can be u squared, and then we have u cube, and then you can see secant squared theta d theta is simply du. So that means this is du, that means this can be du. Now you can see this is a simple integral in terms of variable u. So you can simply integrate this one. But we know that before we integrate, we have to distribute. There are no product rule for integrals. So we have to write this one as u cube plus u to the 5th du. Now what we can do, we can integrate term by term. So it's going to be u to the 4th over 4 plus u to the 6th over 6 plus c. Now what we can do, since we know that u equal tan theta, we're going to put that substitute back into tan. So that means this is going to be tan to the 4th power theta divided by 4 plus tan to the 6th power divided by 6 plus c. So that's how you integrate using the first method. So let's look at the second method. So in the second method, what we're gonna do, we're gonna use the other substitution. So what's the other substitution? We're gonna say u equals secant theta. U equal secant theta. So again, we first take the derivative. So once we take the derivative, this is gonna be du equal derivative of secant is secant tan. So secant theta tan theta d theta. And then so that means we have to isolate secant tan theta term, and also what we can do, we can have the rest of the integral using secant. For that, what we can do, wherever you see tan square term, you can replace this one by secant square theta minus 1. So we can use that substitution. So let's see how the rest of the integral works now. So we're going to start with secant 4th power theta tan cube theta d theta. As before, what we're going to do, we can isolate secant tan term for the derivative. So you can isolate that term. So that means we can rewrite this one as secant cube theta, and then we can take a tan term out. That means we can write this one as tan square theta, and then we can isolate the secant theta tan theta term for the derivative part. So this part we leave it like that. So what we can do, we're going to rewrite the rest of the integral using secant only. Then you can substitute. So this one is secant, so we're going to leave it. And the tan, we can rewrite this one as secant square theta minus 1. And then we already have secant theta tan theta d theta term. Now what we're going to do is we're going to substitute for secant. Secant means u, so this is going to be u cube, and this is going to be u squared minus 1. And then you can see that secant theta tan theta term that we had, that is just a du. So we can write this in a du. So now as before, we're going to distribute first. So it's going to be u to the 5th power minus u to the cube, and then we're going to now we can integrate with respect to u. So if you integrate, you're going to get u to the 6th over 6th minus u to the 4th over 4th plus c. Now you're going to substitute back from secant. So this can be secant 6th theta over 6 minus secant 4 theta over 4 plus c. That's how you use the second method. And you can show that they are all identical. They are all equal to each other using trigonometric identities. So let's look at the third method. In the third method, we use an uncommon substitution here. So we're going to say u equal tan squared theta. Tan squared theta. And the rest of the steps are the same. So we can take the derivative as before, but we have to use the chain rule this time. So du equal, so it's a 2 tan theta times the derivative of tan, which is secant squared theta d theta. So that's what you get for the derivative. Also we have a 2 in front, so that means we have to take care of that. So now let's see how we can manipulate the rest of the argument. So what's going to happen? So we can write this one as again secant 4th power theta tan cube theta d theta. So what we can do, we can isolate tan secant squared term, and then also we have to do some manipulation about the numbers, so that we can talk about later. So we're going to take one secant term out, so we have one left, 2 left, and then we're going to have we take tan term out, so we have 2 tan terms left here, and then what we have is we have 2 tan theta secant square theta d theta. So you can see that there's a 2 here, so that means to cancel that 2, what we can do, we can divide by 1/2. We're gonna write 1/2 in front, so that they cancel each other. Now you can see that they are all identical. Since we have a 2, we divide by 2. Now we can simplify. What we're gonna do now is, as before, we're gonna leave the last part for the derivative. Everything else you have to write in terms of tan squared now. So that we can do using the trigonometric identity. So this is 1/2. And then secant we can write as 1 plus tan squared. And then we have tan squared theta. We have 2 tan theta secant squared theta d theta. Now we can substitute clearly, because this is the derivative part. And then the rest, of wherever you see tan squared, you can plug in u. So that means this is going to be 1/2. So it is 1 plus u squared. Actually it's not u squared, it is u now, because tan squared is u, so it is u, and then tan squared is again u, and the 2 tan theta secant square theta d theta become du. Now what we can do, we're gonna distribute. So when you distribute, you get u plus u squared du. Now you can see that this is very easy to integrate. So if you integrate, you're going to get u squared over 2 plus u cubed over 3 plus c. Now we can multiply through. So when you multiply through, you get u to the squared over 4 plus u to the cube over 6 plus c. Now what we can do, we can substitute for u. U is tan squared. Because of the square here, it's going to be tan to the fourth power. So 1/4 tan to the fourth power plus, again, this is cube. We have already squared, so that means it's going to be 1/6 tan to the sixth power plus c. So that's how we use the second method. So let's go to the third method. In the third method, what we can do, we're going to see whether you can use u equal tan³ theta. And you can see that, yes, that's going to work. So the next method is, we're going to say u equal tan cube theta. So again, as before, we can take the derivative. So du equal, if you take the derivative, you're going to get 3 tan square theta, and then multiply by the derivative of the inside function, which is tan. So that means if you take the derivative, it is secant square theta d theta. So this is again, the steps are very similar to the previous method. So we're going to go with secant 4 theta tan 3 theta d theta. So again, we leave a space here. So again, we can isolate tan squared, secant squared from the integral. So we have secant squared left, and then we have only one of the tan left. So we have one tan left, and then we have 3, that means we have 1/3, and then we have tan squared theta secant squared theta d theta. So again, steps are very similar to previous problems. So 1/3. What we're gonna do now is we're gonna replace secant squared by tan. So when you do that, you know the secant squared is 1 plus tan squared theta, and then we have tan theta. Here we have 3 tan squared theta secant squared theta d theta. And then you can see that we can still substitute here. So what we do, we need one more step. We're going to distribute. Once you distribute, what's going to happen? You can see that you're going to get tan theta plus tan³ theta. That simplifies very well now. And then we have this 3 tan squared theta secant squared theta d theta term here. And that's the derivative part. So we can substitute now. So we can substitute wherever you see tan³ theta, that's going to be u. When you have tan, you can see that that's just the cube root. So that means we can write this one as 1/3 the u cube root here plus u, and the rest of the term simply become du. Now you can see that you can integrate this very well. So if you integrate, you're going to get u 4/3 over 4/3 plus u squared over 2 plus c. And if you multiply it through, you can see that you're going to get u to the 4/3 over 4, because 1/3 and 3 get cancelled. And here it's going to be u squared over 6. Now if you substitute wherever you see tan³ theta, and you can see that you're going to get 1/4 tan 4th power theta plus 1/6 tan 6th power theta plus c. That's exactly the same as the it's the exact same solution. So let's go to the fifth method. In the fifth method, we're going to try the secant option. We already used the u equal secant theta. This time we can try u equal secant squared theta. U equal secant squared theta. And the steps are very similar. So we take the derivative, du equal 2 secant theta, and times the derivative of secant, which is secant theta tan theta d theta. Now what we can do, we can combine them. When you combine them, you're going to be 2 secant squared theta tan theta d theta. Now the steps are very similar from the previous one, so we're gonna go with the argument. We can start with integral. So we have secant 4 theta tan 3 theta d theta, which is equals to, I'm going to leave a space. So we have, so what we can do, we can isolate secant squared tan term. So that means we have one secant squared term left. We have two, so tan squared term left, and then we have 2 times secant squared theta tan theta d theta, except we have 1/2 in front because we have a 2 here. Good. Now what we can do, we can write the except the derivative, but the rest of the integral we can write using tan. So that's using secant, that's we can do. That means we can write this one as secant squared theta. This one tan we can write as secant squared theta minus 1, and the rest we can leave to secant squared theta tan theta d theta. Now what we can do, we can substitute. So remember that when you substitute, we change the variable at the same time. You can't just change the part of the integral to u and part of the integral to theta. We can do that. Either every whole integral will be in terms of theta, or whole integral will be in terms of u. Okay, that's how we have to write all the steps now. So okay, otherwise it's wrong. So what happened now, this is, you can substitute for this one. So it's going to be secant square means u, so it's a u, and then it's going to be u minus 1, and then you can see 2 secant square theta d theta is simply du. So we have du. This is a very simple integral. We distribute first as before, so u squared minus u du. This is very easy to integrate, so you're going to get 1/2. So this is u 3 over 3 minus u squared over 2 plus c, and then when you multiply through, you get u 3 over 6 minus u squared over 4 plus c. Now we can substitute for u. So since u equals secant squared, so you're going to get 1/6 secant to the 6th power theta minus 1/4 secant to the 4th power plus c. Next we use u equal secant cube theta. So we can say u equal secant cube theta. So steps are very similar. We can take the derivative. So du equal 3 secant square theta times the derivative of the secant, which is secant theta tan theta d theta, and then we're going to combine. So we can write this one as 3 secant cube theta tan theta d theta. Now you can see that we can isolate secant cube and tan term, so we're gonna rewrite the integral. So we have secant 4th power theta tan 3 theta d theta. So we're gonna isolate secant cube term. That means we have one secant term, and then 2 tan terms, so tan square theta, and then we have 3 secant 3 theta tan theta d theta, and then we also have 1/3 outside. Now what we can do is we try to rewrite the rest of the integral using secant cube. So to do that, what we can do, we can write the secant theta tan squared, we can replace as secant squared theta minus 1, and then we leave the rest of the integral. So secant cube theta tan theta d theta, and you can see that once you distribute, you're gonna get secant cube theta. That's exactly what we want, and we can also gonna get one secant theta term, and then we have 3 secant cube theta tan theta d theta. And now we can substitute. So we can substitute for this. So it's going to be secant cube means u. minus secant means u cube root, and then we have this is simply du, because this is a du term. We can integrate this one very easily. So this is 1/3. Integral of this one is u squared over 2 minus u add 1 and divided by the same term, and then plus c, and then once you multiply by 1/3 you're gonna get u squared over 6 minus u 4/3 over 4th plus c, and then since u equal secant cube, you can write this one as 1/6 secant to the 6th power minus and then this gonna be secant cube, so 4/3 means, so this gonna be 1/4 secant to the 4th power plus c. That's how we use the secant cube theorem. So let's do the next one, the 7th method. In this method, you can try u equal secant 4th power. So secant 4 theta. So steps are similar. So du equal 4 secant cube theta, and then secant theta tan theta d theta combine. So it is 4 secant to the 4th power theta tan theta d theta. So this is 4. Now again we can rewrite isolating those two terms. So that means we can start with integral. So it is secant 4 theta tan 3 theta d theta. So we're gonna take all the secant terms out. So secant terms is gone. So we have only tan squared term. So tan squared theta, and then 4 secant 4 theta tan theta d theta 1/4. So 1/4. What we can do, we can write secant squared tan squared as secant squared theta minus 1, and we leave the rest 4 secant 4 theta tan theta d theta, and then you can see that secant squared means square root of u now, because we have 4 is 2, so square root minus 1, and then you can see this whole term is simply du. So this is a very easy integral. So it is 1/4. So if we integrate, you're gonna get u 3/2 divided by 3/2 minus u plus c. If you distribute, you're gonna get u to the 3/2 over 6 minus 1/4 u plus c. Now you can substitute for u. Since u equal secant 4th power, you end up getting 1/6 secant 6th power minus 1/4 secant 4th power theta plus c, as expected. Okay, so let's go to the last method. So what we can do in this method, we can convert this whole problem into sine and cosine. So we can convert to sine and cosine. Sometimes this works. So actually it's like it always work, because you can use a different substitution. So this method always work, but it can be lengthy sometimes. It can do much faster in certain problems. So secant 4 theta tan 3 theta d theta. So we're going to convert. Since the secant is 1 over cosine, the first term you can write as cosine 4 theta. Since tan is sine over cosine, you can write this one as sine cube theta over cosine cube theta d theta. Now what we can do, we're gonna combine the terms, so we can write this one as sine 3 theta over cosine 7 theta d theta. Now you notice that there's a odd power. So we talk about when you have an odd power, we can use the other term. That means you're gonna say u equal cosine. So you have to use the other one. So to do that, what we can do, we can isolate one sine term. So we can write this one as sine square theta over cosine 4 theta, and this is the isolated term, which is a sine term. So sine theta d theta. Now what we can do, we can use the substitution. But before that, actually, what we can do, we're gonna rewrite sine as 1 minus cosine. So we can write this one as cosine square theta over cosine 7 theta times sine theta d theta. So it's clear what's the substitution. So we're gonna pick u equal the other one, that means the cosine theta. And then once you take the derivative, so it's a du equal negative sine theta d theta. So that means we can substitute now. So it's going to be 1 minus u squared over u to the 7th, and this going to be you can see sine theta d theta means negative du, so you can put the negative sign outside and you can write this one as du. So you can see that this is a very simple integral, and let's see how to finish the rest of the integral now. So we can multiply by the negative sign and divide by u7, and then you can write this one as 1 over u to the 5th power minus 1 over u to the 7th power du. So you can rewrite this one as u to the negative 5 minus u to the negative 7. Now this is very easy to integrate. So if you integrate, you're going to get u to the negative 4 over negative 4 minus u to the negative 6 over negative 6 plus c. So that means this one you can rewrite as u to the negative 6 over 6 and minus u to the negative 4 over 4 plus c. Now since u equal cosine theta, you can see that u to the negative 1 is equal secant theta. So that means you're going to get 1 over 6th secant 6th theta minus 1 over 4th secant 4th theta plus c as expected. So these are the 8 different ways to integrate secant 4 theta tan cube theta d theta. So please let me know if you know any other methods, and you can write them in the comment section. Thank you for watching.